Welcome back again. This is 6-7, and as we've gone through how to work these problems and the relationships with the gases, we've kind of left out the mole thing and the amounts, the grams, and all that. And so now, lest you thought that we weren't going to do that, we're going to go through that a little bit with this. You remember Avogadro, I hope, who had the 6.02 times 10 to the 23rd molecules per mole and all that. Well, he also did some things with gases, so we can't get away from him. His law is that the volume of the gas is directly related to the number of moles. Okay, so this is another top-bottom one. You keep T and P constant, and so V1 over N1 is equal to V2 over N2. So you know the drill on these. Okay, all we have to do now is just plug that relationship in. You have 0.75 moles, okay, and so that's going to be N1, and you have 1.5 liters equals V1, and then you have 1.2 moles that you're changing it to, so that's N2, and then the volume is what you're going to be looking at. So go ahead and set this up. I know you can do it because we've been doing these for quite a while now. Okay, so we're going to be solving for V2, right? So N1 over V1 equals N2 over V2, or V1 over N1 equals V2 over N2. We know we can do it either way, so V2 equals V1 N2 over N1. Alright, so we've got everything in the same, they're in moles and all that, so V2 is equal to 0.75 moles times the, V2 equals V1, see, I have to really watch myself, 1.5 liters times N2, which is 1.2 moles. Y'all like that when I do that, I know. Divided by 0.75 moles, because even the teacher is not perfect, and I'm definitely not, especially when I'm doing problems just off the cuff here. Okay, so we got it set up right, I think. 1.5 times 1.2, then divided by 0.75, and I got 2.4 liters. Okay, and so did they. All right, now when we talk about working with moles, it's important that we talk about a concept called STP. STP stands for standard temperature and pressure, and basically that means at standard temperature and pressure is really when these calculations are going to work. And so standard temperature is going to be 0 degrees C or 273 Kelvin. Standard pressure is 1 atmosphere or 760 millimeters of mercury. Okay, so if I say something's at STP, you automatically know what the temperature is and what the pressure is. Okay, so I don't even have to tell you what it is, because all I say is at STP, and then you know exactly what that means. Okay, so, and they use this a lot in using moles with these, because at standard temperature and pressure, okay, and remember what that was, 0 degrees C or 273 Kelvin and 1 atmosphere pressure, 1 mole of gas occupies 22.4 liters, and that's called its molar volume. Okay, remember we had molar mass before. In gases we have molar volumes. Alright, so 22.4 liters is equal to 1 mole of gas. Alright, and again, you can always flippity-flop them, okay? So, just like the molar relationship with grams and molar mass, if you have 1 mole of helium, okay, that's 4 grams of helium because it's He 2, right? So at 273 and 1 atmosphere, 4 grams of helium is 1 mole of helium. But if you have oxygen, which is O2, 1 mole of oxygen is 32 grams, but guess what? It will still occupy 22.4 liters. Nitrogen, 28 grams is a mole of nitrogen. That's how much it'll take to occupy 22.4 liters. So it's a molar relationship that you can use as a conversion factor in your dimensional analysis. Okay, so this is very similar to what when we were doing molar masses, except we're just doing molar volume using the 22.4 liters per mole, but it has to be at STP. Okay, all right. What is the volume occupied by 2.75 moles of nitrogen gas at STP? Well, they give you 2.75 moles. Okay. What is the volume that it's going to occupy? Well, you know that you've got moles of N2, and if you want to know the volume of N2, you use the moles per liter to get there. All right, and so what you're going to do is you're going to say 2.75 moles times 22.4 liters per 1 mole of nitrogen. And so the answer is that it would take 61.6 liters of nitrogen for at STP to be 1 mole of nitrogen. Or for 2.75 moles of nitrogen. 1 mole of nitrogen would only be 22.4, but you had 2.75. That's why you had to do that calculation. What is the volume at STP of 4 grams of CH4? Now, think back. If you're given 4 grams of CH4 and we want to know the volume at STP, the first thing we got to do, remember back, we had to convert it to what? Moles. Okay, and so carbon is 12 plus 4 H's gives you 16 grams, I believe. So 16 grams of methane is 1 mole of methane. Okay, so that'll tell you how many moles that is, and I believe it's 0.25. Yes, so that gives you 0.25 moles. And it wants to know the volume at STP, so you know that there's going to be 22.4 liters if you had 1 mole. So you can use that conversion factor. So 5.6 liters. Okay. Now, they're going backwards with you a little bit on this one. It says you've got 8 liters. How many grams? Okay, well, you've got 8 liters of helium. All right, and helium gas is going to be He2, right? I think. Yeah. Okay. Just want to make sure they were using He2, so, or He, 2 of them. So, sorry. So 8 liters. Sorry about that. That was one of those squirrel moments. Squirrel. 8 liters of helium. So we can find how many moles that is of helium. 1 mole of helium would occupy 22.4 liters at STP. All right, and then I can just go ahead and because I can cancel my liters. Remember the dimensional analysis we used, and we know that there are 4 grams of helium in 1 mole of helium, and those will cancel. And so then we just say 8 times 4, 32 divided by 22.4, and I got 1.43 grams of helium. Okay, and that's bear with me because I'm not looking at my periodic table and I don't have everything memorized. So, and this is like what the 7th one in a row of these I've done. So, feel my pain. Okay, so anyway, you can go through all those steps, writing the plan, conversion factors. It's got all the detail right there for you. But they did get the same answer I did. So, there you go. That's molar volume. That's Avogadro's law. And so any gas at STP, the molar volume is going to be 22.4 liters. And I will see you back for the next section.